Hello and welcome to Education at SSBJ online video tutorial. Like in the previous video tutorial where we have studied the first law of motion given by Newton, with the help of a simulation, we are using a same simulation. Please visit this site. So thankful to this simulation, because this particular site will provide you many science simulations where you can interact and learn. Interact in the sense, for example, suppose if I can take out this 100 kg and keep a 50 kg, and then I apply a force, force. You see, I am applying 63 newtons. I increase it and then it starts moving. You come to know now here that 50 kg mass can be made to move when you apply 199 newtons of force, right? But wait a minute, suppose if I make the friction lot, right, this moving object will slow down and then finally it becomes zero velocity or zero speed. Suppose if I take this and bring this 100 kg weight, right, a bucket which contains some liquid or a water which is of 100 kg, and I keep the friction, let's say we keep the friction more here, and I make the person to push it and it will not be able to push. So in this case what I have to do, I will bring the friction. So we understand that if you reduce the friction, then you can push it, right? So like this you can do so much of interaction with this site and learn. Okay, we are here to understand what is the Newton's second law of motion. Like we have learned in the previous video tutorial, Newton's first law of motion. And what is that Newton's first law of motion? A body which is at rest continues to be at rest, right? A body which is at rest continues to be at rest if there is no force on it which makes it to move, right? And suppose if the body is in motion, how to make this body is in motion? I will make friction totally zero, right? Very smooth surface, almost nil friction, and then apply a force, and then you will find it is a moving body. It moves forever provided a friction is zero, right? How good it would have been if we make a track of having no friction. Let's say a bus traveling on a road with no friction, you just push a bus, the bus will move forever without any fuel. Well, now if you want to stop it, you have to apply force. Let's apply friction force which is in opposite direction, right? I'll increase the friction and it stops. So what Newton said, that a body which is in motion will continue to move unless a force acted on it. A force can be a friction force or any force which is applied externally, such as if it is left, by applying some force I'll make still a friction less and then it's moving, and you can apply force on some other direction and stop it. So what is the conclusion of the Newton's first law of motion? A body which is at rest will remain at rest. A body which is in motion will continue to be in motion unless an external force is applied on it. Okay, so I am applying an external force and it comes to zero and start moving in opposite direction. Now again, to stop it I have to move right, because a friction is zero, it will continue to move. So I'll make a friction more and then it stops. And this property of every body is called inertia, right? So this law is also called as law of inertia. Now as far as second law is concerned, Newton has given a relation between a force, mass and acceleration. That is what about the second law. What is that? He has related force, mass and acceleration. He said that acceleration of the body, right? An acceleration of the body, let me take a smaller weight, an acceleration of the body, and I'll make friction very less and I'll push her, and you will find in the acceleration there is an acceleration, right? You can see here acceleration, and acceleration is because of this velocity. If the velocity changes, I can even bring the speed here, which will give you a velocity. Now acceleration is reduced, and over a period of time acceleration comes to zero, because there is no force which is on it. There is a force which is an opposite force, that is called friction force, and acceleration becomes zero here, right? So Newton said this acceleration is depending on the mass, right, and the force applied. Let me repeat, acceleration depends on mass and force applied, right? Let's say, suppose I take 40 kg mass, right? I apply, 199 newtons of force. Look at this, speed is increasing and I am leaving it. So there is some amount of acceleration which was initially, and then it is deceleration, it is going down. And look at the speed, how it reduces. So what I do now is I will increase the mass of this. So this girl I'll replace from, well, I'll take her here and keep 50 kg body here. And same 199 newtons of force I am applying. Now the speed will be less and acceleration also will be less. Okay, it will come fast down and to zero, right? And the body will come to rest, right? Now suppose if I increase this, I'll keep it here, I'll increase 80 kg person here, let him sit here, and then apply same 199 newton of force. Look at his, so I have to adjust here, 199 newtons of force, and now speed is increasing and I leave it, acceleration will be less. It's very simple to understand. The more the mass, less will be the acceleration. Let me repeat this sentence. More the mass, less will be the acceleration, keeping the force constant, right? How much of force here? 199 newtons. If you keep the force constant, okay, the person who is pushing with the same force he is pushing for everyone, but you increase the mass of that object which is to be pushed, then what happens? Acceleration, suppose if you push this 50 kg or somebody who is sitting on it, it becomes 130 kg, and then the same amount of force will produce less acceleration, right? So this acceleration and mass is inversely proportion. Let me tell you what is that. Inversely proportion. And what do you mean by inversely proportion? If one increases, other will decrease. So what is decreased here? Acceleration is decreased. More the mass, acceleration is less. Still the mass is more and acceleration is less, right? And therefore Newton said acceleration is inversely proportional to the mass. Let me repeat again. Acceleration is inversely proportional. And what does it mean? More the mass, less the acceleration. More the mass, less the acceleration. And what does acceleration means? Change in velocity. Of course, it's a straight line motion, so speed and velocity is same here. Right? So this is the first point of what Newton said. The second point is, about how the acceleration depends on the force. Right? Now, for example, if I keep a 50 kg weight and apply around 196 Newton of force, you see the speed and the increase of force. Suppose if I increase the force, see the speed and still increase, okay, and I have left it. Once again, we'll do the simulation here. I'll off it and increase the friction so that it can come to rest. Now friction is more, right? Now you can see here, as I increase the force, the speed increases as well as acceleration also increases, right? So increase the force, the speed increases as well as acceleration. Look at the acceleration one. The acceleration also increases. More the force, more will be the acceleration. So what to conclude? Force, as the force increases, the acceleration of the body also will increase. Now, how do we express this mathematically? Acceleration is directly proportional to the force, right? That is first point. And the second point is acceleration is inversely proportional to the mass. And what does it mean? As the force increases, we will have more acceleration, and as the mass increases, the acceleration will be less. Now let us try to express mathematically and arrive into a final format of Newton's second law of motion. So once again, recall what Newton has said, that acceleration of the body, if I write acceleration A, if I write A here, it's an acceleration, right? Acceleration. And F stands for, you all know, it's a force. And M is for mass, mass of the body. What Newton said, that acceleration is dependent of force and mass, which means if you change either force or mass, the acceleration also will change. Let's say there is an object of mass m and F is the force applied on that object, and the object, let us suppose that moving in a acceleration of a meter per second square. So what Newton said, that acceleration, let me write here point number 1 again, acceleration of the body is directly proportional to the force applied. So what does it mean? As the force increases, the acceleration also will increase. Obviously, because if you increase the force, if you kick a ball with a more force, its speed will increase, velocity will increase, and the acceleration also will increase. Right? And that is what is called direct proportion. So how will you write that in mathematics? It will be written like this: acceleration is directly proportional to the force. Right? If it is written like that, let me take it as equation 1. Acceleration is directly proportional to the force, which means more the acceleration, you need to apply more force, or vice versa, more force and you will get the more acceleration. Right? Point number 2 is about the relationship between mass and acceleration. Right? Mass and acceleration. So what does it says? That acceleration of the body is inversely proportional to the mass of the body. So how will you write this? And what does it mean? Inversely proportional. As the mass increases, acceleration will come down. Suppose if you apply the same force on a body of double the mass of this, definitely the acceleration will be less. Right? So more the mass, less will be the acceleration. But how will you write? Acceleration is inversely proportional, and that is written as 1 upon, what is that dependent variable? Is mass. So this is point number 2. Now look at this. Acceleration is directly proportional to force and acceleration is inversely proportional to mass. So it is read as acceleration is inversely proportional to the mass. The moment you read as inversely proportional, the mass goes to the denominator. So now let me write by 1 and 2, by 1 and 2, we can combine that. Acceleration is proportional to, this is in the numerator F and this is already in the denominator M. Right? Now the entire this format, let me write, I'll just do a cross multiplication here. M will be multiplied to A, so M into A is proportional to force. So how do you read? Product of mass and acceleration is directly proportional to the force. Right? Or I can write force is directly proportional to the product. Look at this. I am writing product. You should not miss this word. Product of mass into acceleration. So this is what the final format of Newton's second law of motion. Did you understand? So what can be the statement now here? You can, if it is asked in the examination, you can write complete like this, or you can simply say the force applied on a body, this is the force, is directly proportional to the product of the mass and acceleration. But how is that format has come? You should know that how it has come. This is the information what is derived from Newton's second law of motion. So far what we have learned is about first and second law of motion, right? Second law of motion given by Newton. Now, not to forget these laws, let us conclude this video by recalling the first law as well as second law. So what does first law tells us? So let me write here, first law of motion, Newton's first law of motion. Let me write here Newton's, right? So credit should go to Newton, father of physics. So what does he says? The body which is at rest or the body which is in motion exhibit a property called inertia. And what is that inertia? If the body is at rest, it continues to be at rest. If the body is in motion, it continues to be in motion. And that property is called inertia. So the Newton's first law tells us that if a body is at rest, it continues to be at rest, or if it is in motion, it continues to be in motion unless an external force is applied on it. So this we have learnt in the previous video. We had 2 videos on this force and acceleration chapter, right? This is the first law of motion, and this law is also called by the name law of inertia. Either you call it as a Newton's first law of motion or law of inertia, TIA, right? And what is the Newton's second law states? Newton's second law of motion states that force applied on a body is directly proportional to the product of mass and acceleration of the body. That is, if the force F is applied on a body of mass m, and if the body moves in an acceleration of a, then F is directly proportional to mass into acceleration, that is the product of mass and acceleration. So in short, you can write the statement of Newton's second law as force applied on a body is directly proportional to the product, many times we miss this, product of mass and acceleration of the body. This is what the statement you can write in class 9. But you should remember how we have arrived to this format, right? So this is what we have learnt in this video, and next video we will start with the Newton's third law. Okay, thank you.